Hello and welcome to my channel. Today I will show you how to build this magnetic pendulum. The pendulum itself is a metal rod with a hole where we insert a brass axle. And it makes a good pendulum with low friction. The coil is made with magnet wire size 27 AWG. It has around 15 ohms of resistance, but it is not a critical component. You can use a slightly different wire size or another size of coil. You can always compensate with the applied voltage for differences in your coil. Here's the pendulum mounted on a frame, a neodymium magnet and the coil. The polarities of the magnet and the coil are such that they repel each other when we energize the coil. Let me turn on the power supply and we can see. Now we need to figure out a way to energize the coil at the precise moment when the magnet is passing above the coil, so that it pushes the magnet to the other side, then turn the coil off and turn it on again when the pendulum swings back. In this way, we will give a push to the pendulum at each pass over the coil. Let's now see how the pendulum works. We have here a reed switch or magnetic switch that closes in the presence of a magnetic field. That is the field of the magnet at the end of the pendulum. So when the pendulum comes in this direction, the switch will close when it is near the center of the coil and will activate this MOSFET, which in turn will pass current to the coil, activating it. However, there is a problem with this approach, and is the following. When the switch closes and activates the coil, the magnet is in this position, so the coil will try to push the magnet in the wrong direction. In order to correct that situation, we have added a capacitor in parallel with the coil. What is the function of the capacitor? Okay, when we are here in this position and the MOSFET passes current to the coil, that energy will be absorbed by the capacitor, which has less impedance than the coil. The capacitor will take a fraction of a second to charge. After it charges, the energy can go to the coil. But that fraction of a second is enough for the pendulum to move just passing the center of the coil. So when the coil energizes, it will push the magnet in the correct direction. As the pendulum travels, the capacitor will discharge through the resistance of the coil. So when the pendulum swings back, the capacitor is now discharged and the cycle can repeat in the other direction. Let's now see the pendulum in action. Okay, I will apply 10 volts. Let me put a counterweight at the top. Now I have disconnected the capacitor and let's see what happens. Here's the pendulum circuit. We have the MOSFET, the magnetic switch, a couple of resistors, this is the coil and capacitor, and we need a diode in order to absorb the voltage spikes when the coil is disconnected. Without the diode, we will burn the MOSFET. Thanks for your visit to my channel. I hope you liked the video and see you in the next one.